All right, welcome back. So now we're ready to introduce the idea of what's called integration by parts. This is a process that's used to reverse the product rule. Let me give you an example of how this idea works, why we choose to do it, because it'll help us integrate some functions that otherwise we would not be able to work out. So consider, for example, this function here, x cosine x, and we want to do its derivative. So by the product rule, that would be x times the derivative of cosine. Cosine is negative sine, so that would be minus x sine x, plus the second function there, cosine times the derivative of x, which would just be cosine. Okay, so now we turn around and let's say that I want to do the integral of that minus x sine x part. Right. See, my normal way of approaching integrals, our substitution and all the other techniques we looked at, it just falls on its face here. But when we recognize that minus x sine x is part of this derivative for the product rule, then things actually work out really well. Because see, I can solve the equation up above for minus x sine x. I just got to bring that cosine to the other side. Now that I'm doing an integral, I would also just apply the integral to the other side. So this would be the integral of the derivative of x cosine x dx plus the integral of cosine x dx. But the integral of a derivative is just that function, x cosine x. Again, within reason with a constant. And oops, I had a sign error. I had to bring cosine over, so it's actually minus that integral. And then that's minus the integral of cosine, which of course I can work out. I know the integral of cosine, so this would actually just be x cosine x. Integral of cosine is just sine, and then plus our constant. So that's the idea behind the method, but I need it to know ahead of time for what I just did, that x sine x was part of a product. I actually had to know the whole original derivative for this to work out. Our integration by parts is going to say, okay, I just know that that's part of a product. Okay, part of a product rule. We're going to figure out what product rule it was part of, and then we'll go from there. Okay, so that's how we kind of approach it in practice. So this thing I just did required me to pre-know that. Okay, what we're going to do, our method won't require us to pre-know that. We'll actually figure out what function it was a part of a product with. And that'll be something we do as we work the problem out. So this is just an example to show you how the concept works. And if something is part of a product, and we just happen to not know the other part of that product rule result, then we can carry that integration through. Okay. So here we knew that, so I could solve for that and then integrate everything. And now, even though I can't work that integral out, I know that it's actually the result of differentiating this function. And you could verify the derivative of this function to show that it does actually come out to be that. Okay, so let's derive this product rule process now. So first thing we do is we recall the product rule. We recall the product rule. And what that says is if you had a function u and v, u times v, then it was u of x times v prime of x plus v of x times u prime of x. All right, that is our product rule. So what we would do is we would say, okay, so that's the product rule. Let's now integrate both sides of that product rule. Integrate both sides. So that would give me the integral of a derivative is just u times v. On the other side, I would have the integral of u of x times v prime of x dx plus the integral of v of x times u prime of x dx. Okay? And so then what we do is we solve for this thing. We solve the equation for this thing. Okay. So that's going to give me the integral of u of x v prime of x dx is equal to uv minus the integral of v of x u prime of x dx. Okay. And then what we do is we call this original thing here u, and we call this v prime dx dv. Over here, we call that v. So the notation is just a little simpler to work with. And we call that du. Call that du. So that the integration by parts formula looks like this. The integral of u dv is equal to uv minus the integral of v du. And of course, this process working revolves upon the idea that this is something we have trouble working out. This is something we have trouble working out, whereas the integral of v du is something we can do the integral of using some of our integration techniques. So that's the idea behind it. So we're going to see how it works here in some upcoming examples.